There we go. Now I'm unmuted, I can talk to you. Good morning to those of you in Europe and Africa. Good afternoon and good evening to those of you joining us from Asia. And a very warm welcome to you all. Thank you for joining this, our 8th of the regular series of short courses on pumping topics. This one will last about 35 to 40 minutes, which will allow us time for a Q&A session after the presentation. As in previous sessions, we're trying to maintain educational content rather than product placement. So I've tried to speak about BB5 pumps generically rather than specifically. But of course, most of my products are raw pump and product. We are into session 8 now, and I expect most of you have attended one or more of the previous sessions. So I'll fast forward past the usual 4 or 5 slides, reminding you who we are and what we do. And we'll get on with the topic at hand. So let's restart the presentation. And here we go. So bypassing these usual slides, let's get on to this one. So this seminar is going to look specifically at double case barrel pumps, API type BB5, but I am going to spend a bit of time looking at why and when you need them and what the alternatives are. You'll see lots of examples of such packages at the end of the presentation, and those of you who joined early have already seen some of those. We'll be holding a Q&A session at the end with as many attendees as we have here. A fully interactive Q&A is impossible. Let's see, how many have we got? We have 200 people registered, and so far we've got about 80 people on board, so that's pretty good. We've averaged over 200 attendees for all the previous sessions. So it won't be a fully interactive Q&A session, but we'll do the best we can. Please use the Q&A facility at the bottom of your screen. I say the Q&A section, that one is better than the chat. Please use the Q&A rather than chat at the bottom of your screen to ask any questions or make any comments. I'll address those that I can live at the end of the session, and the rest I will answer by email in the coming few days. We are recording this session, and we'll make it available to all attendees as both as a YouTube video, and also we will send you a PDF version of the slideshow. So, double case pumps, when do you need them? Well, basically, when your BB2 pumps run out of puff, you need a multi-stage pump. So single stage BB2s run out of head about 300 meters if you're at 50 hertz or 500 meters at 60 hertz. Of course, there are two-stage BB2s, and they run out of heads at about 600 meters and 800 meters. Limited range, of course, on BB2s. Beyond that, that's when you have to start looking at a multi-stage pump. And we have BB3s, BB4s, BB5, and VS6s. So let's look briefly at these 4 options. The BB4 ring section, tie bolt design, it's not fully compliant with API 610, but it is frequently used, particularly in boiler feed and desalination services. It's a good, inexpensive, high efficiency design, ideal for non-process applications. Will take you up to about 1,500 cubic meters an hour, or 6,600 gallons a minute if you prefer, and 3,700 meters, 12,000 feet. The next option is BB3s. Now, they've had limitations imposed by API 610 on temperature, pressure, and specific gravity. but don't let that necessarily stop you from choosing them. This is what API 610 says. Pumps with radially split split casings are required whenever temperature is 200 degrees centigrade or higher, relative density is less than 0.7, and discharge pressure above about 100 bar. Note, it's not a combination of these three, A, B, and C, that leads to the radial split requirement. Any of these three triggers the requirement. This one of relative density of less than 0.7, that would mean that an ethane, propane, or butane pump would always need to be a double case pump. But there is an important rider here in this bullet point number 5 here, which basically says that if you've got good experience with using split case pumps, then you can consider still using them. I give here a reference to an article by Simon Bradshaw on this subject. He considers it, and I agree with him, to be something that API 610 got wrong. It shouldn't be looking at this, and Simon Bradshaw very well writes in this article that I link there that you should be looking at the partial pressure of hydrogen. That's the key thing. So read that at your leisure, and we'll move on and look at a BB3. So this is a BB3. It has back-to-back impellers, half facing one way, half facing the other. So the flow comes in at this side. There's a nozzle here hidden behind, equivalent to this one, but it's here where you can't see it. So the flow comes in here to the first stage, second stage, third, fourth, fifth. Then it crosses over and comes back 6, 7, 8, 9, 10, and out here. This is the joint that API 610 is worried about. They're concerned that there'll be leakage across this big, flat, wide expanse. Now, note how this design has double row bolting, or as I prefer to call it, interstage bolting, with bolts here, here, and here, between each stage to ensure that you get good gasket compression and avoids the risk of washover between stages. Here's an example of a pump that doesn't have this interstage bolting, and you can see the washover, particularly at the center bushing, where the delta P is greatest. Now, this is the real pump and design, but it's not unique to us. I know for a fact that Flowserve does it similarly, and I recall from my days when I was at Flowserve pointing out to customers quite how many pumps we had in propane and butane service. So don't write off a BB3 for propane and butane service. I won't spend too long on this. It duplicates a little of what I covered in session 4, selecting the right pump for the application. But here are 2 or 3 slides on BB3s. Real Pump has 2 designs for the lower capacities, 10 to 350 cubes. It's a diffuser design called the JTN, and for higher flows, it's the SM, which is an Axially, which is a double volute design. So this is the smaller diffuser design. So you see the diffusers here. Used a lot in boiler circ and desalination again. Here's the range chart for that smaller, the lower head sizes, 300 cubic meters an hour and 700 meters head at 50 hertz, or 2,000 gallons a minute at 3,000 feet, 60 hertz. This is the larger model, the double volute design instead of a diffuser design. I went through that, of course, a couple of slides ago. And here's a range chart for that. Goes out to about 1250 cubic meters an hour at 1500 meters of head, or 6,000 gallons at about 6,000 feet head at 60 hertz. Now this flow range is typical of other manufacturers as well. I mean, of course, this is a raw pump and range chart, but you'll find that other manufacturers have a very similar range. Now, of course, light hydrocarbons, C2, C3, C4, they're likely to have high vapor pressure and low NPSH available. So you may well need a VS6 pump, and that's an API compliant double case pump anyway. This is traditionally used when you have very low or even zero NPSH available at grade. It works on the basis that if you've got zero NPSH at grade, if you've got zero here, then 3 meters down, you've got 3 meters of NPSH available. So we make the pump long enough by putting in spool pieces as necessary to position the first stage impeller low enough to give you sufficient NPSH margin. But it's not just an NPSH saver, it's a space saver too. It takes up 20% of the floor area of the equivalent BB2 or BB3. And it's a cost saver too. You've only got one seal, one sealing system, and it's less expensive than the equivalent BB2 or BB3. But civil engineers don't like digging holes. There can be good reasons, such as water tables and groundwater quality. But if you can persuade them to do so, then you're on a potential saving all the way. So of course, big users for these pumps, C2s, C3s, C4s, condensate water in power stations, ammonia, and liquid oxygen, liquid nitrogen. Is the range chart for the semi-engineered VS6, approximately 1,000 cubic meters at about 850 meters head. And of course, we have engineered versions available that go well outside this range. So here we are now, about 14 minutes into the presentation, and we finally get around to BB5s. The BB5, the double case pump, used when you have no other choice. High temperatures, high pressures, low SG. Now, this is generic, not specific to raw pumping. So they're radially split, they're horizontal multi-stage, centerline mounted, usually diffuser type, sometimes volute type. They can have a single or double suction first stage, depending on your NPSH available. Usually with a top-top nozzle arrangement, as shown here. But it can be side-side or side-top. Normally have back-to-back impellers and so opposed impellers, back-to-back impellers that will balance out the thrust, or if they have inline impellers, they'll have a balance drum and can run up to about 6,000 RPM when needed. Applications, this is when you'd usually use them. Water injection, use some of the biggest ones of all, I think. There's a range chart. This is the raw pump and range chart and covers the more standard or usual range, if anything can be considered standard or usual for this type of pump. It's an engineered pump, of course. This range chart is pretty similar to the Sulzer, SPX, and FlowServe range charts, but of course, we all have built-to-order specials that are out here or up here on the chart. But this is the general range for most manufacturers, about 50 hertz, 1100 cubic meters an hour, and 2778 meters of head, or 6,000 gallons and 13,000 feet if you're American. So here's some features of the pump. Here we see the outer case, which may be a casting or a forging. There are three different casing constructions, which I'll come to in a minute. There's the integral drive end cover, the separate drive end cover, and the twist lock designs. I'll come to those in the coming slides. Top nozzle configuration, most common, can be side-side or side-top. Here's the inner case, which may be an axially split volute type, or more commonly, as shown here, a radially split diffuser type. The impellers may be in line, all facing in the same direction, or as we show here, and more commonly used, is back-to-back. So the flow comes in through the suction nozzle, into the first stage, over to the second stage, to the third, enters this passage here, bypasses and back into the fourth, fifth, sixth stages, exiting here. Now, back-to-back construction means balanced thrust, so that means you can most often you can use ball type anti-friction type thrust bearings. On larger and higher speed pumps, then we would use tilting pad and sleeve bearings. And those, of course, require a separate lube oil system, so it starts putting up the size, weight, and cost of your system. Here we see the balance line that equalizes the seal chambers from drive end and non-drive end. It also acts as a drain line for the suction, the low pressure areas of the pump. Here is the non-drive end cover. Release these bolts and you can pull out the inner assembly in this direction. Now, the previous slide showed the more common diffuser type construction. Here we see the less common volute design. You could think of it like a BB3, an axially split case pump, inside and outer casing, making it double case. As I say, it is less frequently seen, and it's for the following reasons, really, that they are volute designs are generally bigger and heavier. The inner case being a sand casting, it's bigger in diameter and has more material. Diffuser designs are balanced. The radial loads are balanced in diffuser designs, whereas they're not so effectively balanced in a volute design. So it's less forces on your radial bearings. You have the option, the ability to put blank or dummy stages in to allow for future changes in head if you foresee a future increase in required pressure. You can replace individual stage pieces with the diffuser design, and you can change the hydraulics easily within the same outer casing, so same footprint. You can usually fit one or two different hydraulics within there and change the duty in the future. These are things that are much more difficult to do with the volute design. I mentioned a minute ago that you'll see three different outer casing designs. Here are the two most common: the complete pull-out design, which has a separate drive end cover. Let me show you that. Here we go. Here is the cover that I'm talking about, and it's separate, a separate forging from the outer case. It's part of the inner casing. So the whole cartridge assembly, including the end bearing housing and the mechanical seal, can be withdrawn in one assembly without any disassembly required. Pulls out in that direction, like this. Maintenance engineers prefer this solution as it minimizes the number of loose parts to be tracked and handled. The second type is the integrated or integral suction cover design. Now here we see the drive end, or the suction cover, is integrated into the barrel casting or forging instead of being a separate piece. Okay, so it's all part of the same casting here, whereas if I go back to the previous slide, you see it was a separate piece with a trapped O-ring in there, confined O-ring in there to act as a seal. Design engineers prefer this design as it's a more rugged, robust design. You know, engineers, it's got to be tough. It also doesn't require an O-ring seal, clearly, as I showed in this. An O-ring seal at this point there between the separate cover and the casing, because it's integral, all part of the same casting, obviously no O-ring required. Now it is still a pull-out design, but you do need to do some disassembly first. You need to remove this drive end casting, bearing housing, and the mechanical seal. Then the inner assembly pulls out like this. Let's talk briefly about back-to-back arrangements. Half the impellers face one way and half of them face the other way. This balances the thrust. And it means that ball type bearings can be used even on quite large pumps. And so removing the need for a force feed or separate lube oil system. There are designs out there with inline impellers, all facing the same way. And those have a higher residual thrust, which has to be balanced out either with a balance drum, and also it will require a hydrodynamic tilting pad thrust bearing and a force feed lube system. So back-to-back is more commonly seen, especially on larger ones. Inline impellers are most commonly seen on smaller pumps where the thrusts are not so great. Also on pumps where with fewer than about 6 stages. If you have fewer than about 6 stages, suction and discharge nozzles can tend to interfere with each other. Here we see the balance line, which connects the 2 mechanical seal chambers, so they see the same pressure and can have the same seals. Except, of course, that one's going to be a clockwise seal and one's going to be an anti-clockwise seal. With an integral flange, integrally casting to the case casting or forging. And there we see the butt-welded balance line. It also acts as the drain connection for the suction areas of the pump. And you have a separate connection for the discharge areas of the pump, again, integrally flanged. And you can see it here is the integral flanges there, and here is the pipe. The case, the cover sealing, this area here. Now this is, okay, we have a confined O-ring in this area here. And we're showing here a metallic O-ring, which offers superior sealing because it's simultaneously under compression and tension. See, we've got compression from the bolting here, and you've got it in tension because we drill holes in the O-ring. And so you've got fluid pressure entering in there. So that's pushing outwards, and you've got compression pushing inwards. So simultaneously in compression and tension. Wide range of operations. And here's a good point. No tight fit seal required between the cartridge OD and the barrel ID. We're not sealing it radially, we're sealing it axially. So this can be a loose fit inside the barrel. Now this is the third casing design that I mentioned earlier. It's the Sulzer twist lock design. No bolting with this design, no bolting here as we had here on the conventional design. With the twist lock design, you just slide it in and twist. So no bolting, which you might think it's an advantage, but on the other hand, you can't use an axial seal in that position there because it requires compression from the bolting, which you don't have. Instead, it uses a radial seal. Here we see it, the radial seals here, this point and this point. Supported by anti-extrusion rings because it sees high pressure and would otherwise they might well squeeze out. This design has to be an interference fit within the barrel, and so it needs a hydraulic ram to install it and remove it. And if you're not careful in doing so, you can damage the O-rings. Here are some aspects to think about with the twist lock or radial seal design. High probability for snagging the O-rings. High pressure is acting against these O-rings, so you need the anti-extrusion rings. The alignment needs to be perfect when you install it, and you need a hydraulic ram to install it. And these extrusion rings, shear rings, are process wetted, so there's a risk of localized corrosion. The perceived advantage of the twist lock system is that you get rid of the bolting, and the bolting, of course, would require a hydraulic bolt tensioning tool. Now, honestly, that's not an issue on a large site, as you'll already have hydraulic bolt tensioning tools there on site for compressors, large pumps, gas turbines, and so on. But it might be more of an issue on remote sites. This is the coolest thing I think I ever saw. A multi-jack bolt tensioning tool. Widely called super bolts, though that's actually the trade name of Nordlock. It allows you to tighten the bolt, the nuts, using conventional hand tools. You tighten the nut by tightening each of the jack bolts in turn, and you can use conventional hand tools. And you can buy a super bolt tool to make it even easier. Here you see the jack bolts being tightened, all 8 together. This is a link to the Nordlock site, and you can see a YouTube video of this in action. It really is very cool. So moving on from the casing, let's take a look at the rotor. We see a stepped shaft being smaller in diameter at this end and this end, and larger in diameter at the middle. So with the stepped shaft, each impeller is located by split rings or by shouldering, so it cannot move in the axial direction and distributes the force equally along the shaft. Bearing cooling options, showing here anti-friction bearings, which are used on most pumps. But we also have hydrodynamic sleeve and tilting pad bearings, which are used on larger and higher speed pumps. So this one is air-cooled with a finned bearing housing. This one fan-cooled with the addition of a fan here. and this version water-cooled. Just going to revisit the inner cartridge removal process. This uses a special mounting tool shown here in red. Firstly, this is the integrated, this is the complete pull-out design, like that. Now the integral cover design. You see you remove the bearing housing on the drive end, and then it comes out like that. And here are some photos of the tool. You can see this is in our service shop. This is a pump being serviced. You can see the diffusers here, and here back to back, and here are the outlet, the discharge from those diffusers. And as I mentioned earlier, it's a loose fit in the barrel, not an interference fit. It's a clearance fit. These are very much engineered pumps. Specialist for pumping technology is Ruhrpumpen's byword throughout the industry, and we use German engineering throughout, using the latest engineering tools. Computational fluid dynamics, CFD, or finite element analysis, FEA, and every pump we have rotordynamic analysis. I now have about 15 slides of barrel pumps. I guess you could consider this to be the product placement part of the presentation. Those of you who tuned in early will have already seen these already. I'll go through them fairly quickly so as not to bore you and to allow us time for the Q&A. So here is one that is on the Statoil Valemon platform, full NORSOC compliance. Very congested package, obviously bound to limited space. You'll see quite a few that are on decoking water. Decokers is a big part of Ruhrpumpen's product line. .2 megawatts going to China. As I said, I'm going through this fairly quickly. You'll have this in the presentations. You can look at it at your leisure in more detail. This one is being on string test in the Ruhrpumpen factory. 3.2 megawatts motor being tested with the pump. .2 megawatt one here at 4,000 RPM through a gearbox. And this, you see our test bay here. We have capacity of 6.5 megawatts and flows of 15,000 cubic meters an hour and supplies of 10 kV. But we can go higher than that by using the Siemens facility at Duisburg, where we can go up to 17 megawatts. This is actually an Axially split case pump. I've shown this one because this is an offshore unit with a 3-point mount. There's 1, 2, and there'll be a 3rd point on the other side. Now, this is commonly used on offshore platforms. And I'll leave you with this thought. Well, that pretty much concludes the fun for today. So I just get to advertise the next of the short courses, which is going to be on understanding pump instrumentation, especially vibration monitoring equipment and what the readings obtained tell you about your pump installation. 4th of November, that's 3 weeks today. Again, 2 sessions, one for the Eastern Hemisphere, one for the Western Hemisphere. The invitation will be announced soon. 4th of November, the clocks would have gone back here in the UK, so we're back onto GMT. So be careful, watch, have a look and see what that does to the local time for you. I know, for example, in India, you don't change your clocks, and so the time difference becomes 5.5 hours instead of 4.5 hours. Future sessions, probably do one on non-destructive examination. And after that, I don't know yet. What would you like us to cover? So give it some thought, send me an email, things you'd like us to cover in these short courses, smith@rawpumping.com. Let me know. So I'll leave this meeting open for a little while to allow you to post in the Q&A box. And I'll endeavour to answer those that only need a short answer here and now. Those that need a fuller answer will be answered within a few days by email from our marketing people. Anything you think of later, drop us an email at info@rawpumping.com or direct to me at smith@rawpumping.com. Our marketing team is standing by to direct your questions to the best person to answer them, and they will be sending you the YouTube recording and the PDF of this presentation. If you need a certificate of completion, again, info@rawpumping.com. Now, on with the Q&A. Let me have a look and see what we've got in the Q&A at the moment. Mahmoud Taha says, can we get a copy of the presentation? Will it be shared? Yep, it will be. You'll get it early part of next week. Asad Farid Qatar says, thanks a lot, Simon, for the good presentation. You're welcome. Would it be possible to get a copy soon after the press session? Yes, I'll have this over to marketing tomorrow, and they'll probably send it out Monday or Tuesday of next week. It also says the last session slides are yet to be received. Would love to have them as a reference. Asad, could you send an email, please, to info@rawpumping.com and remind them that they haven't had it? Something may have gone wrong. Maybe it's in your overloaded your email or in your spam folder or something. So do just drop a note to info@rawpumping.com and ask our marketing people to resend it to you. Ugo Erman says, can you please tell us more about thermal effects on parts like thermal expansion and compression, depending on the 3 different casing designs? Yeah, that's not easy for me to do live, but yes, it's a reasonable question, and I'll discuss that with our engineering team and come up with an answer in the next few days. Ugo Erman has said, I'd like you to cover ISO 9906 or details of performance test procedures. Yes, I'm doing NDE. I think I can probably do performance testing also either within that same one or maybe a separate one. Yes, good suggestion. Thank you, Ugo. Anonymous attendee has said, cast barrel versus forged barrel. Which way do you think is better in general? It's interesting. When you have a cast barrel, obviously you'll be doing NDE, you'll be doing X-ray analysis. X-ray analysis is going to show indications without question, which will have to be excavated and welded up. You could end up with a lot of welding going on, and it can take a lot of time. So a forging is, of course, perfect. Generally, it's more expensive than casting, but by the time you've taken into account the weld repairs that might be necessary on a casting, the forging it can often be the way to go. So yes, we'll sometimes go either way. Gonzalo San Martin says, any consideration introduced by API 610 12th edition different from 11th edition? I don't believe there's anything in 12th that changes as far as the BB5 is concerned. I think it was my first course was on differences between 12th and 11th editions. You might like to revisit that, or if you didn't get that one, send us a note and we can send that earlier presentation to you. Abhishek Rane says, we have multiple applications in oil and gas services where we require low flow, high head pump types. What are the key points we should consider while selecting between BB5 type and OH6 type? Well, an OH6 type is the high speed pump. It's the Sundyne or Sunstrand pump, integral gearbox, runs at very high speed. Some people love them, some people hate them. People who get on with them, they fill a great niche in the market, and they work very well. Other people don't have good success with them, and they're more familiar with the double case type of pump. So yes, it could be a small barrel pump, or you can go for an OH6 pump. OH6 pump will be less expensive than a barrel pump, but not by a whole lot. There are expensive pumps as well. Yes, I haven't covered OH6 at all in this presentation. It definitely does fill a niche. Ugur Erman says, do you suggest to use a minimum flow valve, an arc valve? If yes, which conditions? Yes, like with all pumps, you do need to ensure that you're operating within the allowable operating range. If there's any risk of you operating at minimum flow, some form of continuous recirculation valve, an arc valve, Yahweh, Schroeder, Schrodal make such valves. Yes, very important. Hingol Limited have said, thank you for the presentation. My question is a 3-stage pump a BB2 pump? Is the pump category based on the numbers of impellers in the pump? BB2 defines a radially split 1 or 2-stage pump between bearings. It's an API designation. So a BB2 is between bearings, radially split, can be 1 stage or 2 stage. Once you get to axially split, that will become a BB3, whether it be 2, 3, 4, 5, 6, 7, 8, or 15 stages. That'll be a BB3. And a BB5 is a double case pump. So a radial split. Inner case might be axially split or radially split, but the main outer casing is radially split. Thangamarapan Ramasabu, I apologize for my pronunciation. Does Ruapumpan have a cartridge type VS6 pump? VS6 pump, there isn't really such thing as a cartridge type VS6 pump. For a VS6 pump, you're always going to have to remove the motor, and then you will pull out the discharge head and the inner assembly together and take them off to the workshop to work on. There's no way of removing the inner cartridge of a VS6 pump without removing the motor first. You can access the mechanical seals, of course, to be able to do those with it in situ, and indeed the thrust bearings too. Mahmoud Taha says, is there a strip test following the performance test? Yes, there would always be a strip test. You would remove the cartridge, break it down. You would look for any rubbing between the impeller wear rings and within the bushings. So yes, on any multi-stage pump, you always have a tear down inspection afterwards. Kiran Pawar says, can you please elaborate the testbed capabilities of raw pumping? I will not do that here, but I will send you details about it. It's different. We've got different test loops in different countries, which can do different, have different capabilities. I'll get some details together and put it into the Q&A session when I pull this all together. Anonymous attendee says, what are the available flange design options if a particular application requires pressure rating above 2500? It becomes an absolute engineered solution. We would come up with the solution that is right for your application. Once you get beyond the standard flange sizes, it becomes more than just an engineered pump. It becomes a super engineered pump, I think. Abhishek Rane says, your views on balancing disc versus balancing drum for the BB5 pump. A balancing disc is not allowed by API 610. It has to be a balancing drum. Now, none of the raw pumping uses a balancing drum on an inline version of the BB5. To be compliant with API 610, I don't think that we have any balancing disc designs. I think others do. API doesn't allow it. It's about all I would say on this one. So I don't think we've gone too far down that route. If I get a better answer from engineering, I'll put it into the Q&A when I compile all my answers to this. Mahmoud Taha, thanks for the interesting presentation. You're welcome. What are the options for the drivers? CSM, VSD, turbine driven? Are they manufactured by your side or get supplied by other well-known suppliers? Yes, we can do it with steam turbines, with variable speed drives, with gas turbines. We work with companies like Solar Gas Turbines, for example, for doing gas turbine driven sets. We don't make the drivers ourselves, so we're always buying from approved motor vendors. We have our favorites, but of course, oil companies and contractors, you have your vendor lists as well of users, of suppliers that you want us to use. So yeah, whichever. Also, testing is performed using testbed drives, or is there room for mounting the job one? Yeah, we frequently do a string test using the job driver. We will normally be using, for the performance test, we'll be using our driver because it's a calibrated motor. So to get the accuracy required on the performance figures, you need a calibrated motor. But we'll often do a string test where we'll use the job motor and the job gearbox and the job lube system as well. Sean Hampson says, using a diffuser will reduce the radial loads. Are there any disadvantages in using diffusers? What are the effects of using a diffuser on impeller diameter? Do we have to reduce the diameter of the impeller? You know, I can't think of any disadvantages of of the diffuser. I think on small pumps, the wall sections might be thinner, perhaps, and so it's less resistant to wear, I would say, but certainly not on larger ones. I think really the volute designs are just old-fashioned now, and I think just about everywhere, Flowserve, SPX, Sulzer, and Royal Pumpen all use diffuser designs primarily. Rajesh Sankaran says, does the balancing line utilize to balance axial thrust with the balancing drum? The balance line that I showed was to balance the seal chamber pressures. But yes, when you're balancing the axial thrust with a balanced drum, you will have a balance line on that as well. Rajesh also says, balancing drum is not required for opposed impeller design. No, it's not, because you've got, say, if it's a 10-stage pump, so you've got 5 impellers facing one way and 5 the other way, the balance is, the thrust is balanced. And so you've got just a small residual balance, residual thrust that is deliberate. We want it to push in one direction by a few hundred pounds, few hundred newtons of force. And a ball bearing is more than capable of that. You don't need a balanced drum. That appears to be all the questions in the Q&A at the moment. Let me just go over to the chat box and see if there was anything in there that wasn't covered. Milagros, I can't see his full name here. Are there safety concerns on using BB4 for water desalination, i.e. sweet water injection pumps? Well, yes, that's why API 610 would require that you have a double case pump for it, but they are widely used. There's a lot of safety built into them. So the market will accept generally BB4s on desalination pumps. Jorge Sos from BP Castellón Refinery. We're using a flow meter in the balance line in our BB5 Royal Pump for the Coke unit to review wear of the balance disc. Any specific trick or behavior to look at? That's a bit detailed for me. I will pass that on to engineering and get an answer for you on that. Anura Disanayaki says, appreciate your presentation. If possible, please share me the presentation. Yep, our marketing department will be sending out this presentation both as a PDF and as a link to a YouTube video. Kiran Pawar says, oh no, sorry, he's just asking for a copy of the presentation. That I've covered. Okay, and Ugur Erman has said, thanks a lot for the presentation. It helped a lot like the previous ones. Looking forward to the next one and appreciate if you can add performance test session. Yes, I think that's a good idea. I'll do a session on performance tests, I think, as well as non-destructive examination. Might do it in the same one or might make it 2 separate presentations. I'll see how it goes. Well, that appears to be all for presentation. Yes, you'll get, early next week, you'll get a link to the YouTube video and also a PDF version of this slideshow. Leon again says, when do we need to think about BB5 instead of BB4 on boiler feed water applications? It's a value judgment. I wouldn't like to put a pressure rating on that. I think I'd like to discuss that with my engineering team and see if they have a feel of when they are unhappy offering a BB4. So I'll come back on that one. Well, that appears to be all the Q&A. Let's have a look in the chat box because there might be some here. Okay, Octavio Manzano says, "Dear Simon, this is Octavio Manzano with Apfelbaum Industrial. Do you have a cross-reference with other OEMs?" Well, we kind of do, but it's an internal document for our internal sales engineers to see the pros and cons of the Sulzer design and the FlowServe design and the SPX design against ours. It's not something we publish, I'm afraid. Can you send me the specifications on this pump? Tell you what we'll do. I'll have our local sales engineer get in touch with you and give you all the assistance you need on that. Erica Prueba says, multi-phase pumping, supercritical CO2 type of fluids. I'll come back to you on that. I would like to get an answer from our engineering experts on this one. Maulik Shah says, how about API 610 12th edition changes overview presentation? Well, that was the first presentation I did back in the summer, session number 1. If you were to send a request to info@ruhrpumpen.com asking for session 1, the comparison of API 610 11th and 12th editions, then they'll send that to you. I don't believe there's anything in 12th edition versus 11th edition that impacts BB5 pumps. Sheldon Solomon, I think, well, when would you choose side nozzles versus top nozzles? Purely for convenience of pipe work. How's your pipe work going to be? With side nozzles, it will not normally be high temperature because you've got rid of the centerline advantage of putting both the suction and discharge nozzles will be in the lower half below the centerline mount. So it'll be for cool applications. So it could be water injection, could be boiler feed. And like I say, it's for pipe work reasons. Okay, I think that is all of them. Let me just have a look and see if there are any more in the Q&A. Yes. Tyler Payment has said, any thoughts on specialty coatings, specifically regarding produced water injection service? Specifically thinking about the best coating material for the balance drum and wear rings. Thanks again for the great presentation. Well, thank you for your comments. When you're going to BB5s, we are less looking at coatings and more looking at selection of the material. So if it's a corrosive material, we're probably talking about super duplex. So we won't be using coatings. Coatings are going to be used more on lower cost pumps, maybe a BB4 pump for that. Well, that appears to be it. And the time now is 5 to 6 here, which is, well, 5 minutes till beer o'clock. So what I'll say now, I'll close this, this session off and say thank you for attending today. I enjoyed preparing and presenting it. I hope you found it useful. See you on the 4th of November in 3 weeks' time for the next course. Bye-bye. Good evening.